everyone. So today we're going to talk about the distance and midpoint formula to determine the length of a line segment in a coordinate plane, and as well as to determine where the middle of a line segment is within the coordinate plane. Now remember, coordinate plane is our points in the X, Y format. So we use the distance formula to find the distance between 2 points, or the length of a line segment in the Cartesian plane. We represent the points as x subscript 1, y subscript 1, and x subscript 2, y subscript 2. For the majority of this video and most of the time, I will just say x1, y1, x2, y2. And remember, when you're using the Kami software, in order to do the subscript, you will use the formula tool and the underscore. Now there is a very simple formula that we are going to use in order to find the distance between 2 points. It's going to be d equals, which in this instance d means distance, the square root, and I need to be inside the radical for this, x2 minus x1, and then we're going to square that. And remember, on Kami to square we use the caret, which is the shift and the 6 key, plus the same thing with the y's, y sub 2 minus y1, and we're going to square that, and this is going to be the formula we're going to use. So you're going to make a list of your points and then plug them into the formula. So taking a look at number 1, it tells us to find the distance between the 2 points on the graph. So what I have done here is I've labeled the points -5, 3 and -2, -3. So the first thing we're going to do is the same that we do in every single problem that we do in this class. We are going to label and list our givens. So what I'm going to do is I am going to be boxing in my points in a specific color. So I'm going to go ahead and use red for point A, or the first point, and then I'm going to use blue for my other point. And I'm going to be color coding a lot in this lesson. So let's go ahead and, again, like I said, we're going to list our givens. So we will be using the formula tool a lot, and we will be changing the color of our text. So first of all, I'm going to change my color to red because I'm going to list my point 1 first. And it doesn't matter which point is which, as long as you're consistent. So in this case, as long as I always use this red one, so -5, +3 is point 1, then that's what matters. If I had decided that it was point 2, that would have also been fine. So I have x1 is equal to -5, and y1 is going to be equal to 3. Oops. And then we're going to list our other point value. So we're going to go ahead and put this one in blue. So I have x2, and that's going to be equal to -2. And then I have y2, which is going to be equal to -3. So I've made my list, and now I need to do the formula. So again, it's going to be d equals the square root of x sub 2 minus x sub 1. And we're going to square that. So x2. And then we're going to add to that y sub 2 minus y1. And again, we're going to square that as well. Now we got to do our substitution. So what I want to do first is I'm going to use my shape tool, and I'm going to box in where I'm going to put in my red points. So here in the ones. I'm going to do the same thing with my x's, or my point 2, so that when I do the substitution in the next line, it will be just as obvious where I got it from. So again, we're going to hit our formula tool. We're going to hit distance is equal to the square root, and we're going to fill from our list. So x2 is -2 minus -5, and again we're going to square that, and then we're going to add -3 minus 3, and we're going to square that as well. And then I'm going to use my shape tool, and I'm going to go ahead and color code this. Again, you do not have to do the color coding but I do recommend it. It is a good way to organize your notes and keep track of where things are coming from. Boxing in. Now the next thing I need to do is go ahead and put it into the calculator. So I could manually type it, or I can use copy paste, and I get 6.708. I'm going to round to the nearest hundredth, which means that in this instance, the distance is approximately equal, and that's the double squiggle mark, 6.71. In this class, I won't get after you if you don't use the approximately equal, but it's good to know that it exists. Number 2, it wants me to find the length of AB, given that A is -4, 1, and B is 3, -1. So first thing we're going to do is we're going to decide which of these is our A, or our point 1, and which is going to be point 2. So in this case, I'm just going to say that A is point 1 and B is point 2. It doesn't matter which is which again. This is just, I usually do the one that's listed first. All right. So the first thing we're going to do is we are going to, of course, list our givens. And then we're going to go ahead and use our formula tool. We're going to have x1 is going to be equal to -4. We are going to then put that y1 is going to be equal to 1. x2 is going to be equal to 3. And then we are going to say that y2 is going to be equal to -1. I'm going to go ahead and box those in as well, same as I have been doing. So I'm going to do point 1, and point 2 is going to be blue. And then I need to go ahead and do my formula. So like we did previously, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1, and we're going to square that as well. All right. So now we've done our formula. Now we need to go ahead and do our substitution. So distance is equal to the square root of x sub 2, which is 3, minus x sub 1, which is -4. And we're going to go ahead and square that. Add to that y2, which is -1, minus y1, which is 1. And then we're going to go ahead and square that as well. And I'm going to copy and paste this into my Desmos calculator. But first, I'm going to box in my x2s and my y2s. And then I'm going to do the same thing to my point 1. Okay. And then after I run that through the calculator, I find out that we get 7.28. So the distance between point A and point B, or the length of AB, is going to be equal to approximately 7.28. So AB is approximately 7.28. Number 3, we have find EF, given that E is -7, -2, and F is going to be 11, 3. And all we're going to do is start by listing our givens. Every problem, every time. This is not just for this class. I promise this is going to be helpful to you in future classes as well. So our first x value is going to be -7, and our first y value is going to be -2. And then our second, our second x value is going to be 11. And then our second y value is going to be 3. Oops. All right. I'm going to go ahead and color code. So I've got my point 2s and my point 1s, my first point and my second point. And then of course we did our list. So now we're going to do our formula. Again, in our formula tool, distance is equal to the square root of open parentheses, x2 minus x1 quantity squared, and then add y2 minus y1. And again, we're going to square that as well. So that's our list. Let's go ahead and again do our color coding. So I've got x2, y2, x1, y1. All right. So our substitution is going to say that the distance between these 2 points is equal to 11 minus negative 7, and we square that, add to that 3 minus negative 2, and we're going to square that as well. Now you can go ahead and calculate this all the way through if you wish. So we have 11 minus negative 7 is 18. Then we have to do 18 squared, and then we have 3 minus negative 2, which is 5. 5 squared is 25. So 18 squared, which of course I don't know off the top of my head, 324. We're going to add the 25. And then we're going to take the square root of that number that we got. So that's square root of 349. We get 18.68. Of course, we could have done that more quickly by copying and pasting the the entire expression right into Desmos. But we're going to go ahead and round that to 18.68. So the length of EF is approximately 18.68. And again, this is another one of those situations where if they don't give us units, we are not obligated to give units back. So we could say this is 18.68 units, but since they did not give me units, units do not necessarily need to be returned. Now we're going to discuss the midpoint formula. Of course, it is exactly what it sounds like. It is used to find the midpoint between 2 other points. It is also used in reverse to find the endpoint when given one endpoint and the midpoint. So there are 2 ways to express this formula. There is a traditional format, and then there's the split up format that I prefer. So what I'm going to go ahead and do is I'm going to put over here on the left hand side the traditional format. So it's midpoint, and that's in of course x, y format is going to be equal to, and then we need a fraction, x1 plus x2, oops, 2, and we're going to divide that by 2, and comma, fraction y1 plus y2, and we're going to divide that by 2. So that's what the traditional formula looks like. However, again, I prefer to break it into 2 pieces because it's easier to find an endpoint if you have the broken up formula. So the x value of the midpoint is going to be equal to, and I always put the fraction bar in first. So we have x1 plus x2 divided by 2. And then we're going to go ahead, and I think I'm going to make that a lowercase n. Yeah. We're going to go ahead and add the y version. So again, y of the midpoint is going to be equal to, fraction bar first, y1 plus y2, and we're going to divide that by 2 as well. Like I said, this is going to make it easier for us to go backwards with. So up first we have number 4, which says find the midpoint of segment GH given that G is 7, -5 and H is 9, -1. Now again, we need to make sure that we are going to highlight the points. X1, doesn't matter which one's 1, which one's 2. I just tend to go left to right. We're going to list our givens, And I'm going to go ahead and do that on this right hand side where there's more space. Using the formula tool, I'm going to say that x1 is going to be equal to 7. And then I'm going to say that y1 is going to be equal to -5. And then x2 will be 9. And y2 is going to be -1. So this is our list. I'm going to go ahead and color code. So again, my point 2's and my point number 1 are formulas, and I'm just going to do 2 of them separately. So we have x of the midpoint is going to be equal to x1 plus x2 over 2. That's going to be equal to 7 plus 9. So again, my fraction bar first. 7 plus 9 divided by 2. And you can say 7 plus 9, that is going to be 16 divided by 2 will be 8. But if the arithmetic makes you a little bit uncomfortable or you just want to double check your work, you can always use the calculator. Please do not allow the arithmetic to be what causes you to be lost. Make sure that you always ask or use a calculator. All right, there's nothing wrong with that. So I have my color coding. So now I have x of the midpoint. So I need to find the y of the midpoint now. So I'm going to use my formula tool. Y subscript m is going to be equal to fraction bar y1 plus y2, and that's divided by 2. Again, we're going to set that equal to -5 plus -1, and that's going to be over 2. -5 plus -1 is going to be -6. And when we divide that by 2, we get -3. So the midpoint of this line segment GH is going to be 8, -3. And remember that is going to be with a comma, and there needs to be parentheses around it. Number 5, they want us to find the midpoint of segment AB, given that A is -7, 4, and B is 3, -4. So again, first thing we do is list our givens every single time. So our first thing we know is that x1 is going to be -7, and then we have y1, and that's going to be 4. Then we have x2, and that's going to be equal to 3. And finally y2, and we're going to set that equal to -4. So there's our list of givens. And then I'm going to be writing out my formulas, both of them. So we have x of the midpoint is going to be equal to x1 plus x2 over 2, and that's going to be -7 plus 3. Fraction bar first. -7 plus 3, and we divide that by 2. And we get -2. Now that we have found the x, let's go ahead and find the y for the midpoint. So y of the midpoint is going to be equal to, again, y1 plus y2 is going to be divided by 2, and then that's going to give us 4 minus negative 4, and that's going to again be divided by 2. 4 minus negative 4 is 8 by 2, and we get 4. Okay. All right, so now we have our x of the midpoint and our y of the midpoint. So that tells me that the midpoint of this segment is going to be negative 2, 4. Now we're going to use the midpoint formula to go backwards and find a missing endpoint when we are given a midpoint and one endpoint. So make sure you put right here, must be given one endpoint and the midpoint. That is a minimum of information. So if we look at number 6, it says find the coordinates of A if the midpoint, M, negative 1, 2, is the midpoint of segment AB, and B has the coordinates of 3, negative 5. So again, I'm going to go ahead and do some color coding. I'm going to say that point B is going to be my x2, and my midpoint is going to be purple, and A, which is going to be my x1, is going to be red. So again, we're going to list our givens. What do we already know? And the answer is going to be that we know that the x of the midpoint is going to be, I'm just going to call it x of m, is going to be negative 1. And we know that the y of the midpoint, so y sub m, is going to be 2. And we are given x2 and y2. So let's go ahead and include that information. X sub 2 is 3, and y sub 2 is going to be negative 5. You can also call this x sub 1 and y sub 1. It does not matter if it's 1 or 2, as long as you call it 1 or 2. So make sure that all of the points you've labeled 2 stay labeled 2. Now we're going to use our formula. Again, we're going to do it split apart, again, because it's easier this way. So the x of the midpoint is going to be equal to, it's actually the average of the 2 points. So we are unknown x sub 1 added to our x sub 2, which in this instance we do know. We're going to divide by 2. Right. We're going to do our substitution on a separate line this time, because we do already know the x of the midpoint. We know that's negative 1, and that's going to be equal to x sub 1 plus our x sub 2, which is 3, and we're going to divide by 2. Now we have here our x is in the numerator of a fraction. Now to get rid of a numerator, we have to multiply both sides by the denominator. This is because fractions are division. But fractions are also a grouping. So if we are following our order of operations backwards, like we do when we solve, we would do addition and subtraction first unless it's stuck inside a grouping. So we don't have any addition and subtraction we can undo here, so we have to undo the multiplication first. The way we are going to do that is we are going to multiply both sides by 2. So the easiest way to represent that in this format will be our times 2. It's not my preferred method though. I would prefer to put it in parentheses and do it in a different color, or not do it on this separate line. I would usually do this on the same line. But after multiplying both sides by 2, I am left with negative 2 is going to be equal to x plus 3, and it's x sub 1 plus 3. And then, of course, my next step would be to subtract the 3 from both sides. So we're going to do our minus 3 And that leaves us with negative 5 is equal to our x sub 1. So now we have the x value of the endpoint 1. Now we need to find the y value of that point. So again, we're going to enter in the formula. Y of the midpoint is going to be equal to, fraction bar first, y sub 1 plus y sub 2 divided by 2. And then we do our substitution. So we already know that the midpoint's y is 2. And then again, fraction bar first, y sub 2 plus, sorry, that's the PUD, y sub 1 plus negative 5 is going to be divided by 2. And again, our next step, we need to multiply both sides by 2. Again, another thing here is normally I would not use the x for multiplication, but for the purposes of making it in the next line, normally what I would do is use the dot for multiplication. That is my preferred method. And to get that, it's just the star key, shift and 8. It is the better way to do this for advanced maths. So 2 times 2 is going to be 4, and that's going to be equal to y sub 1 minus 5, because plus negative 5 is minus 5. Then I'm going to add 5 to both sides. And that's going to leave me with 9 is equal to my y sub 1. Which tells me that A is going to be at negative 5, 9. So that's my final answer. I'll box it in. Number 7, find the coordinates of J if K, negative 5, 10, is the midpoint of segment JL, and L has the coordinates of negative 8, 6. So again, let's go ahead and do some color coding. We are finding J, which again, I'm just going to call my point 1. We are given L, which is going to be my point 2. And we're given K, which is the midpoint. So our list of givens will include that. X2 is equal to negative 8. It's also going to tell us that y2 is equal to 6. And then we have x of the midpoint, which is going to be negative 5. And we have y of the midpoint, which is given to us as 10. All right, so I'm going to apply the color code. Again, x2 and y2 are going to be boxed in this blue color, and then I use purple for the midpoint. We've got our list. Now it's time for our formula. So x of the midpoint is going to be equal to x1 plus x2, and divide by 2. On this one, we will continue down on the same line. So our x of the midpoint is going to be negative 5, which will be equal to our x1, which is unknown, plus our x2, which is negative 8. And we're going to divide both sides by 2. Or not both sides, sorry, divide that fraction by 2. In order to get rid of the denominator, we need to multiply both sides by 2. And again, I am going to use the dot for multiplication because it is more correct than the x. It can't be mistaken for an x anyway. So we have negative 10 is going to be equal to x sub 1 minus 8. And then we're going to add 8 to both sides. So after we do that, we will have that x sub 1 is going to be equal to negative 2. Now that we have the x, now let's go ahead and find the y. So again, we're going to enter our formula. Y of the midpoint is going to be equal to y1 plus y2 over 2. Now we substitute in the known values where y of the midpoint is 10 and y sub 1 is unknown. We're going to add 6 and again divide by 2. Next step is the same as well. We're going to multiply both sides by 2 in order to eliminate the denominator on the right-hand side of this equation, which leaves us with 20 is equal to y sub 1 plus 6. Final step is going to be subtract 6 from both sides. Which will leave us with an answer of 14 is equal to y sub 1. And then what we're going to do is put that information together to reflect the final answer. So our final answer is that J is going to be located at -2, 14. Number 8 asks us to find the coordinates of R if Q, -1, 3, is the midpoint of segment PR, and P has coordinates of 5, 6. So again, we're going to start this problem off the same way we do every other problem by listing our givens. So in this instance, we are again given the midpoint and point 2 or point 1, your preference. So I'm still going to call it point 2. So x sub 2 is 5. And then we have y sub 2, which is going to be 6. And again, we're given the midpoint, so x of the midpoint is going to be -1. And y of the midpoint is going to be 3. We're going to enter that information into our formulas. So again, we're going to start with our broken apart formula for finding an endpoint. So our formula is x of the midpoint is equal to our x sub 2 and x sub 1 added together. So x sub 1 add x sub 2. And after we put the formula into our box, we are then going to put in the information we already know. So we know that the x of the midpoint is 3. And then we do not know x sub 1, so we're going to leave that as is and add 5. And that's going to be divided by 2. And then we need to undo the division. So we're going to multiply both sides by 2 in order to get rid of that denominator, which will give us -6 is going to be equal to x sub 1 plus 5. We will then subtract 5 from both sides, because in order to move from one side of an equation to the other, you have to use inverse operations. Remember, if you're staying on the same side, you do not have to use inverse operations. And in fact, you should not use inverse operations if your numbers are on the same side of the equal sign. Inverse operations are exclusively for moving terms from one side to the other when it comes to solving the equation. Please make sure you're not using inverse operations if they are both on the same side. Now we're going to repeat all of that, but with the y, of course. So y of the midpoint is going to be equal to y sub 1 added to y2 and divided by 2. Substitute in the known information. So y sub m is 3, and that's going to be equal to y sub 1, because we do not know what y sub 1 is, added to 6, and again divided by 2. Once again, we're going to multiply both sides by 2 in order to rid ourselves of the denominator there, which will leave us at 6 is equal to y sub 1 plus 6. And then we're going to divide subtract 6 from both sides. We are going to subtract 6. And that's going to give us 0 is equal to y sub 1. Now, please remember, 0 is a number and can be a potential answer. So do not assume that just because you ended up with 0 as your answer, that you're wrong. Okay, please remember, 0 is an appropriate answer. The final answer on this problem is that r is located at -11, 0. For the next 3 problems, we're going to take what the definition of midpoint is, which is the location where we cut the segment exactly into 2 equal pieces, and we're going to use that information to solve some algebra problems and find the value of x, or in the case of number 10 and 11, we're going to find the length of a segment. So again, first of all, just like every other problem, we are going to list our givens. So we are given that P is the midpoint. So what that means is the picture, now if we draw a picture, this segment is cut exactly in half. So I've drawn a picture here. I'm going to label it with the points that I was given. And I don't necessarily have to do this on every problem, but it's a good idea to do for some of these earlier problems. So P is the midpoint. Now remember, when you have a midpoint given, that indicates that the segments are equal. So this one, PY and XP, are congruent. So we're going to add that into our list of givens because that is the definition of midpoint. So segment XP is congruent to segment PY, which means that the length of XP is equal to the length of PY. XP is given to us as 8x minus 2, and PY is given to us as 12x minus 30. And again, the equation that we're going to use is right here already. So we have it as part of our list of givens right here. XP equals PY. So I set those two expressions equal to each other. So we have 8x minus 2 is going to be equal to 12x minus 30. I'm going to move my x's. So I like to move the 8x because I prefer to stick with the positive x's. And it does not matter which side of the equal sign you leave your x in the end. So I prefer to have my x's be positive. So now I have -2 is going to be equal to 4x minus 30. On the next step, I'm going to add 30 to both sides, because remember, when I want to move a term, any term, from one side of the equation to the other, I have to use inverse operations. -2 plus 30 is 28. And then I'm going to divide both sides by 4, which will leave me with a final answer here for x of 20. So 7 is equal to x. And since that is what they wanted me to find, I can stop here. I do want you to get in the habit of boxing in your answer. You should already be in the habit already. Moving on. Number 10. I'm not going to draw a picture for this one now. We're just going to picture this as G or F, G, and H. We can tell G is the midpoint, FG and GH, because G is an endpoint for both segments. So we know that's the one that's on the interior. So we're going to list our givens. which in this instance, because G is the midpoint, that indicates to us that segment FG is going to be congruent to segment GH, which in turn means that FG, the length of FG, is equal to the length of GH. And again, that's the equation we're going to use to set up our solution. So FG is 14x plus 25, and GH is going to be 73 minus 2x. Now I'm going to set those two expressions equal to each other. So I'm going to have 14x plus 25 is equal to 73 minus 2x. Again, I'm going to move my 2x this time because it's being subtracted. I want to add it to the other side. So again, add 2x. And that's going to give us 16x plus 25 is going to be equal to 73. Then I'm going to subtract 25 from both sides. Let me pull this back up. So minus 25. And that's going to leave me with 16x is equal to 48. And then we're going to divide both sides by 16. Which is going to leave us with x is equal to 3. Now they did not ask us to find f8 or x, they asked us to find fh. So we're going to remember that fh is equal to fg plus gh. And since they're going to be the same, we can choose which one we want to calculate with. So we can either do 73 minus 2x, or we can do 14x plus 25. Either way, we can run it through the calculator. So I'm going to go ahead and do GH, which is 73 minus 2x. So GH is 73 minus 2x, which is 3. And then we're going to take 73 minus 2x, and 2x is going to be 6, because 2 times 3 is 6. And we get 67. So if GH is 67, then that indicates to me that FG is also 67. That FG is also 67. And so you can either multiply by 2 here, or you can just say that FH is equal to 67 plus 67. And that's going to give us 134. Yes. So FH has a length of 134. Last question. Using the diagram to the left, if N bisects QR, find QP. So basically we're just going to make sure we mark that they are congruent, because if N is a bisector, then that means that P is the midpoint. So let's go ahead and make our list of givens. This one's going to be a little bit easier. So we are given that since N is the bisector, P is the midpoint. So that tells me that segment QP is congruent to segment PR, which means that the lengths are equal. So QP is equal to PR. We are also told that QP is equal to 3x plus 5, and that PR is going to be equal to 5x minus 19. We're going to use the QP equals PR equation, so let's do our substitution. We have 3x plus 5 is going to be equal to 5x minus 19. I am going to subtract 3x from both sides. And that's going to leave me with 5 is equal to 2x minus 19. I need to move the 19 to the other side of the equation, so I'm going to go ahead and do that by adding it to both sides. And I am left with a final, or next line of 24 is equal to 2x, which means that x, after we divide by 2, will be 12. Right? Again, they didn't ask me for x, though. They asked me for QP. So we have QP is going to be equal to 3x plus 5. We are going to substitute in the now known value of x for 3 times 12 plus 5. And 3 times 12 is 36 plus 5 is 41. So the length of QP is 41. And there's no units given, so no units must be returned. So that's all I have for you for this lesson. If you have any questions, let me know, and I'll see you next time. Stay safe.